All right, well, I hope everybody's having a good day. We will pretty much wrap up Hyperbolas today. There's just a few things left that I want to go ahead and show you as part of the lesson. We have a focus activity. Remember, we've already turned in numbers 1 and 2, so this next set starts with 3, and we'll at least get a 3, 4, 5, and then, we'll go on from there. But what is happening tomorrow? Not a test. Quiz over what? Ellipses. There we go. It's going to be an ellipse quiz. All I did was put a couple of word problems on there. Shouldn't be too bad. Okay, so look over your material. I'll be passing back your papers today as well. You can look over those. Also, tomorrow you'll get the homework assignment. I'll talk to you about when it's going to be due, but you'll have time to work on that tomorrow as well once we're done with the quiz. And then on Friday, it looks like we're going to be able to start parametric equations, which is good. It is going to slow down a little next week, unfortunately, because Tuesday, Wednesday, Thursday, we've got star testing. So it's going to be late start days, shorter periods in the afternoon. So you'll either have the morning off or you'll be taking the test on a particular day, depending on your situation. But big picture, we've only got 3.5 weeks left. And things are going to be going pretty quick. Probably in a couple of weeks, we'll have our second exam because by district policy, we got to have 2 of 6 weeks. We'll have the homework grade for the hyperbolas. We'll have the quiz grade, focus activities. So there are still several grades left if you're a little concerned about your average. Okay, but if you need anything, just let me know. Are there any questions? Bless you. The STAR test, I know that Tuesday is Algebra 1. And then is it social studies and science, or is it science social studies? Does anybody know? I know those are the 3 tests next week, but I don't know the order of the other 2. I'm hoping social studies will be on Thursday. Hello. Okay, Jack. Cosmo. It says when convenient, so I don't know if you want to hang on for just a little bit, finish the notes, or we're about to do the focus activity right now. Okay. All right, well, let's go ahead and take a look at our focus activity. It says an arch in a memorial park, okay, having a parabolic shape, has a height of 25 feet and a base width of 30 feet. Find an equation which models this shape using the x-axis to represent the ground. State the focus and directrix. Okay, so the first thing I'm going to do is draw a picture. So the ground here is going to be the x-axis. So we have a parabolic arch. Okay, probably looks something like that. And we're given the dimensions. We know that the height is going to be 25 feet. We know that the base width is going to be 30 feet. Now, because we're using the ground as the x-axis, I would probably just go ahead and say the origin is right there. Okay, I'd go ahead and put it on the axis of symmetry for that parabola. All right, so that means that our vertex could be what? 0. Okay, so 0, 25, because remember, that's the height of the arch. Okay, the maximum height. Okay. Well, let's see here. Because it's a parabola that is opening down, the general form we're going to use is going to be, negative 4p. And what variable would be squared? X or y? X. So y minus k is equal to x minus h squared. Okay. Well, we have the vertex, but there's only one other item I would need, and I have my equation. We need what variable? We need p. Okay. Well, let's see. If we already have an h and a k, all right, we have those. If I had an x and a y, well, then I could just plug in and solve the equation for p. Yes, ma'am. Oh, you did something different? Yeah. Okay. Oh, yeah, you can absolutely do that. Oh, yeah. Yeah, so where you place the origin makes no difference as long as the points correspond to that. Absolutely, yeah. So, in fact, let me go ahead and ask you, what'd you get for P? 2.25, 9/4. That's exactly what we should be getting. Okay, good. Very good. So you put your origin right here? Okay, that's perfect. That's perfect. Yeah, it'll still work. Okay. All right, so what I did for the XY point, I went ahead and used this guy right here because my origin's in the middle. I went ahead and said that was 15, 0. Okay. But as long as all the points correspond to where you decide the origin's going to be, you should be able to get the same value every time. So, her equation's probably going to look a little different because of her vertex, and that's perfectly fine. So let's see here. negative 4p. Okay, so I need y minus k. Well, here's the x and the y. So 0 minus 25, so that's going to be negative 25, equals. Now I need x minus h, so that's going to be 15 minus 0, so that's just 15 squared. So it looks like I'm going to have 100p is equal to 15 squared. 225. Okay. So now divide through, p is equal to 225 100ths, or 9/4. And there's the 2.25 that Aiden was talking about. Perfect. Okay. Anybody else already get that before we started? Okay. A few other folks? Good, good, good. So let's go ahead and use our vertex and our value of p. So my equation is going to look like this. If I were to plug 9/4 in for p, what would be my coefficient? Negative 9. And then that would be y minus 25 is equal to, and I'm going to go ahead and plug in the 0, x minus 0 squared. So based on where I put my origin, that is one possible equation for the arch. Okay. All right, well now we just want to go ahead and figure out what the coordinates of the focal point and the equation of the directrix is going to be. So my focal point is on the axis of symmetry, and we know that this distance here turned out to be 9/4. So how am I going to figure out the coordinates of F? What can I do? There you go, 25 minus 9/4. We're moving vertically. So I'm going to go ahead and say, 25 over 1 minus 9/4. So we need a common denominator of 4, so that would be 100/4, because that's 25. Minus 9/4, so it looks like I'm getting what? So I'm going to say that my focal point is at 0, 91/4. Is everybody okay with that? All right. Now, if I subtracted to get down to the focal point, what am I going to do to go up to the directrix? Yeah, I'm just going to add it. So 100/4 plus that distance p. So I'm looking at y equals 109/4. Okay, so there's the focal point, there's my equation, and there's my directrix. Okay, questions? How we doing? Well, okay. Now, like I said, you're going to get at least 2 more, 3, 4, 5. Maybe we'll get more. Depends, like I said, next week the schedule is going to be kind of unusual. But put this someplace safe. I'll be telling you at some point we'll turn those in. Good. And let's talk about some hyperbolas. Okay. So I did show you animation when we talked about ellipses. I want to go ahead and start by doing the same thing for hyperbolas. Remember, an ellipse was constructed using the focal points. If you take any point in space and connect it to your 2 focal points, the sum of those distances always gave you a consistent value, and we realized it was 2a, the distance between the vertices on the major axis. Well, there's just one change when you're talking about hyperbolas. Okay, we're still going to take a point on the graph. We're going to connect it to my 2 focal points, but instead of adding those distances, we're going to subtract them. And by subtracting those distances, we always get, again, a consistent value that we are going to call 2a. That's what this definition is talking about. So let me go ahead and show you this animation here. Okay. What is that? Okay, well, I'll worry about the talking in just a second. But you'll notice as we move along any point on this branch, and it's not just one branch, it could be either branch, these 2 distances, whatever they are, when I subtract them, would always give me 2a. That was weird. That wasn't on there before. That's unusual. Okay, but anyways, maybe I just had it turned down too low. But is everybody okay with that? Does that kind of help with the definition of a hyperbola? I'm sorry, what? What are you saying, Aiden? Oh, ancient forgotten animal vines to watch when you're depressed. Maybe we could revisit that at some point. That does look like an ancient depressed animal, so okay. All right. So let's go ahead and talk about hyperbolas. We diagrammed one yesterday that was horizontal. Let's go ahead and diagram one today that is vertical. Again, just kind of bringing up the terminology, vocabulary, all that good stuff. So there are always two axes for a hyperbola. And what do we call those? One starts with C. The what? Well, one's the conjugate and the transverse. There we go. Which one's the more important? The transverse. The transverse is always going to contain the vertices and the focal point. So if I have a hyperbola that's opening vertically, so we have a branch opening upward, we got a branch opening downward. That means this would be the transverse axis. This is the conjugate. Now where they intersect is our center, and we're going to go ahead and refer to that as HK. All right. Now, of course, they're always perpendicular to each other, okay, just like the major and minor axes of an ellipse. Now, where the transverse axis touches the branches, those are your vertices. So there's a vertex here, there's a vertex here, and then further out along the transverse axis, inside of those branches, remember we're not referring to them as parabolas, because they're not parabolas, we have our focal points. So why don't we go ahead and find the coordinates of those in terms of H and K. But first we need the distances. Okay, so what's the distance, A, B, or C, between a center and a vertex? It's always A. So if I want to go from the center to this upper vertex, what would the coordinate be? So H, and you're saying, Christian? K plus A. There we go. So likewise, going down to the lower vertex, this would be H, K minus A. And I know you already have these diagrams in your packet, but I think it's always a good idea occasionally to talk about them. How far a distance is it from a center to a focal point? Varunda. Is it B or C? Not B. C. There we go. So this focal point right here should be H, K plus C. This one down here would be H, K minus C. So A and C, those distances are always found on your transverse axis. Well, where's B? Okay, he's always found along the conjugate axis. Now, he doesn't play as big a role here. You could use B to find A or C if one of them's missing. You definitely need him for the slope of your asymptotes. But typically what a lot of people like to do, if I were to go whatever distance B is along the conjugate axis, let's say that's a distance of B and this is also a distance of B. So these points here would be H plus B K, and this other one would be H minus BK. One thing we were talking about yesterday you could do, you could use these 4 points, the vertices and those 2 that I just created, to make a rectangle. Now remember, this was if you liked the idea of the rectangle, because what could the rectangle give you? Oh, did someone not? Oh, someone not? Hey, it's going to give you what, sir? The asymptotes. If you draw the diagonals of that rectangle, those are the asymptotes for the graph. Okay. There we go, just like that. Okay. So we're using point slope form to write the equations of the asymptotes. The point is always going to be the center. The only thing we have to remember is the slope A over B or B over A. So for this, we would have y minus k is equal to plus or minus. And what would this look like? Is the slope A over B or B over A? This is A over B. Here, the distance A is vertical. Okay, so that's my rise. B is horizontal, so that's my run. And then it would be x minus h. In fact, what's the relationship between A, B, and C? There you go. We're back to the Pythagorean theorem. A squared plus B squared is equal to C squared. Okay, because C is the longest distance in a hyperbola. And this is what we were talking about yesterday. Okay. Any questions on how it's formed, any of the characteristics, anything like that? Okay. Well, we have just a couple of problems left, and we are done. I believe we were on this one right here. So just a quick recap for eccentricity. Remember, this was a numerical value that described the curvature of your graph, and every conic had a different type of eccentricity. Some of them had a specific number, and some of them had a span of numbers. So let's start with a circle. Okay, Zach, what was the eccentricity of a circle? Not 1. It is a specific number, though. 0. The eccentricity of a circle is 0, okay, because the distance from a center to a focal point is 0. The focal points and the center are the same points. Now let's go to an ellipse. Okay, let's see here. Ethan, what is the eccentricity of an ellipse? Now this is our first interval. It's between 0 and 1. Very good. So 0 less than eccentricity, less than 1. Now let's talk about a parabola. I'm just going to go ahead and put par. Okay. What's the eccentricity of a parabola? Alex. This one is a specific number. One. There we go. So the eccentricity is 1. And we've got 1 left. Hyperbola, I'm just going to go ahead and put HYP. What's all that's left for hyperbolas? It's got to be greater than 1. There we go. Okay, and you're always finding it the same way. You take the distance C divided by the distance A, and here for a hyperbola, C is larger than A. So if you take a number and divide it by something smaller, you're going to get something bigger than 1. Okay, so we would absolutely say hyperbolas are definitely living up to the hype, right? I know there's no E on there, but I don't want to say hip. That's not. I guess you could say they are hip. Yeah. What do you think is better, living up to the hype or parabolas are hip? You think the hype is better? Or maybe I could just say both. There you go. No? You don't say both? No? Okay. All right. I actually just thought of that one. It's nice when I think of them when I'm recording. That's a better way to do it. All right. So 8th period is in for a treat then. All right. So let's go ahead and take a look at completing the square one more time. So we have a general form, and I want to put this in the standard form of a hyperbola. Okay. Now, once we go ahead and do this together, then I'm going to go ahead and give you a few minutes while I pass out some papers, and I'm going to have you folks find the vertices, foci, asymptotes, and eccentricity. And then we'll see if I can get a couple folks up here to go ahead and help me out with that. Okay, so I want to rewrite this in standard form. I know we're dealing with a hyperbola. Can anybody tell me what the first step is? Okay, put the x's and the y's together. Also, I'd want to get rid of what? That 164? Okay, so 4x squared minus 16x. We got a minus 9y squared minus 72y. And then I'm going to add that 164 over to the other side. Okay. Now, what's the one condition that has to be in place in order to complete the square? There you go. The x squared and y squared coefficients have to be a positive 1. So we're going to go ahead and factor these out. So I'm going to pull out a 4. That's going to leave me x squared minus what? Okay, 4x plus, and then we'll find that value in just a second. Now, you got to be careful here when dealing with a hyperbola. We're going to factor out a negative 9. So that's going to change the sign of this linear term. So negative 9, that would give me y squared plus 8y. Because if I were to remultiply that back through to get back to the general form, negative 9 times 8y would have to give me negative 72y. So if you left that as a negative, that means your center would be in the wrong location, and that would give you the wrong information for everything else. Is everybody okay with that? So it's something really, really small you want to pay attention to. Bless you. Equals 164. So let's see, how do I complete the square? Divide by 2 and square it. So I'm going to be taking these linear coefficients here. First, negative 4. So negative 4 divided by 2 squared. That gives me 4, but I'm going to put a 16 right there. Where'd that 16 come from? There you go. Once you complete the square, don't forget to multiply by the number that you factored out. Okay. So now I want to do the same thing for 8. 8 divided by 2 squared will give me 16. Okay. So if I put a 16 here, I'm going to put a minus 144 here. Now, wait a minute. Why is that one negative? There you go. Again, something you want to be very careful about. We're multiplying it by a negative 9. So I'm subtracting it over on the other side. Remember, it has to balance. Okay. And let's go ahead and start to pull all this together. This would be 4 times what squared binomial? X minus 2. And then we'd have minus 9 times y plus 4 equals 164 plus 16 minus 144? 36. Okay. Well, I can already tell that the center is going to be found at 2, negative 4, but there's something wrong. Why isn't this in standard form yet? There you go. It has to equal 1. So I'm going to divide by this constant. Divide by 36. Divide by 36. And luckily, again, these coefficients here are factors of 36. So it looks like I'm ending up with x minus 2 squared over 9 minus y plus 4 squared over 4 equals 1. So there would be the standard form of that hyperbola. Okay. In fact, who haven't I talked to lately? How about Connor? What direction would this hyperbola open? Horizontally or vertically? Vertically? Horizontally. Why horizontally? Okay, there we go. Remember, you decide what direction it's opening based on the positive variable. Okay, because x is positive, it opens horizontally. If y is positive, then it opens vertically. How do we know which one is a squared? There you go. For an ellipse, remember it was always the larger value, but here there's no guarantee a is bigger than b. A squared, though, is always below the positive variable. So a squared, b squared. Okay. So I'm going to go ahead and have you find those 4 items if you haven't already done so. Let me pass back some papers here. And then we'll see if we can't get a couple of volunteers up. Listen. Oh, let's give you. Good. Tuesday. Yeah. Step. Mary. Raphael. Oh, sorry. Okay. All right. So let's see if we can't get a couple of folks up here. We'll get one person to come up, and then you can choose any two of the four you want. Vertices, foci, asymptotes, or eccentricity. And then we'll get another person up here to figure out the remaining two. Do I have a volunteer? Okay. So I'm going to go ahead and use the random number generator, and let's see if it does pop up 34. Because we had that little joke, remember the other day about that happening. Okay, so let's see what happens. Last time it was 6. 24. Good, so that is Raphael. All right. I'd like to thank Raphael for volunteering. Okay, so you get to choose any of the two you want. Okay, so he wants eccentricity. So he says C over A, square root of 13 over 3. And let's go ahead and round that to 1 decimal place. Somebody help him out with that. What is square root of 13 over 3? 1.2. Perfect. All right, so eccentricity is done. And it looks like he's going to do the vertices. 5, 4, and very close. Nope, you were right about that.
Oh, negative.
There we go. So now we need to change one more thing back. There we go. So that negative was correct.
There we go, guys.
Oh, you forgot negative. There you go. All right. So 5, -4, and -1, -4. Does anybody want him to elaborate? Do we agree? Okay, Dylan, yes. Can you elaborate? Okay. So, Raphael, would you kind of start to sketch this for me? I'll just start to sketch it. Like, all we need are the vertices. Oh, now, what direction does this open?
Pretend like it's the other way, okay, guys?
Pretend it's the other way.
There we go. Hang on, let me get the eraser.
Okay.
There we go. And then, here's that one. And here's this one. And there we go. What's that?
Well, he's drawing arrows to those.
The vertices, guys. Magic.
Hey, okay.
Use your creative senses.
There we go.
I volunteered.
Okay. Did anybody want me to kind of help out, make sure we know where those came from? You do, Sabion? Okay. Now, I don't know if my artistic skills will be as good as Raphael, but let's see. So we know it opens horizontally, right? Okay. Let's say this is the transverse. Okay. So it opens like this, opens like this. So let's say that my center, we know it, what was it, 2, -4? So let's say the center is at 2, -4, and we're looking for the vertices here, right? Remember, how far a distance is it from a center to either vertex? That's A. And we know in this case, A is 3. So the distance here is 3. So all we need to do is move horizontally, 3 right, 3 left. So 2 plus 3 is where we got the 5, -4. Well, let me move that since we might put the focal point on here. Okay, so this point right here would be 5, -4, and then this vertex right here, 2 minus 3, is where we got the -1, -4. There we go. Okay, Savion, does that help? Okay. Does anybody want to talk about where we got the square root of 13? Pythagorean theorem. So in the denominator, we already had a squared and b squared, so 9 plus 4 gives me c squared, square root of 13. Okay. All right. Last up, foci and the asymptotes. That'd be a good what?
Foci and the asymptotes.
Foci and the asymptotes? Do you play an instrument? Oh. I was going to say, does anybody here actually play an instrument? Is anybody in a band? You're in a band? What's the name of your band? Oh, you know, foci and the asymptotes.
We have like 20.
Oh, 21. Okay. All right, so let's see here. Next volunteer, 25. Okay. All right. So Satish. Okay, so all I need is the focal points and the asymptotes in point slope form. Okay. And there you go, sir. Okay, so perfect. 2 plus or minus square root of 13 negative 4. From a center to a focal point is C units, in this case square root of 13. Sure. So y plus 4 equals, now this is plus or minus b over a because it is opening horizontally. A is the run. That is it. That would be the equation of my two asymptotes. One with a slope of positive 2/3, the other with a negative 2/3. Questions? Did anybody get anything different? Or is anybody not sure how we got a particular value? Okay. Then one last addition to your notes. I was kind of surprised this resource did not include this, so I wanted to go ahead. Remember, I think it was like a couple of weeks ago, I mentioned briefly that we would be doing this. Given a general form, if I use b squared minus 4ac, depending on the number, I want to be able to tell what kind of conic it is I'm working with without rewriting the equation. Okay, in fact, remember what we call b squared minus 4ac? That's the discriminant. Okay. You remember how you use the discriminant with a parabola to determine how many solutions you have? Okay. Same idea here. You're just looking for a conic, though. All right. So let me go ahead and give you a little bit of time. Now, there are 3 problems that I'm going to have you try. So once you've had about a minute to copy down this first part, then I'll scroll the screen down. But as before, b squared minus 4ac, you're either going to get a negative value, 0, or positive. And depending on which, that will tell you what type of conic it is you're looking at. The one thing I'll mention, that general form up there has a term that we haven't seen in any of our equations yet. Which one am I referring to? I'm sorry? The b, that's xy. Okay, we have not seen an equation with an xy term in it yet. And in fact, that makes sense because of this statement right here. When b equals 0, meaning there is no xy term, your conic is either vertical or horizontal. Remember, in here, we're only looking at the horizontal and the vertical. If you were to include an xy term, that's where you get a rotation. Okay. All right, so let me go ahead and scroll down to this last one. So those will still be on screen. Okay. But now you have the 3 examples. Okay, A is always the coefficient of x squared. B is the xy coefficient. C is the y squared coefficient. Okay, so you just need those three, b squared minus 4ac. Try that for these three problems. Okay, but one of them might be surprising to you. And let's see if you can figure out which one. So for each of these, try to figure out what type of conic it is we're dealing with. Yes, sir. C is always the coefficient of y squared. A is the x squared coefficient. B is the xy coefficient. C is the y squared coefficient. So this question's already popped up. What's the value of B if there is no xy term? 0. Okay, there we go. Has anybody figured out yet which one I was referring to? Which one are you getting an answer that you did not expect? The first, the second, or the third example? Ooh, not the third. Second. Something about that second example. Hello. Thank you. Okay, Dylan. Okay. Because remember, we've briefly talked about this, just being able to look and tell, but that's not always 100% accurate. And you'll see what I mean in just a second. Is everybody ready, or do we need a few more seconds? Okay. So why don't we go ahead and start with the one that I was referring to. Now this one here, you'll notice there's two squared terms, okay, which makes me think circle, ellipse, or hyperbola. They're both positive. Okay, and you'll notice the coefficients of x squared and y squared are what? They're the same. So just by looking at it, I would probably think what? Circle. Okay, but this one is different. It has the addition of an xy term. All right, and let's go ahead and apply the b squared minus 4ac. All right, so what is b in this case? B is 4. Okay, so b squared, 4 squared, minus 4 times a. A is the x squared coefficient, times c, which is the y squared coefficient. But you'll notice that's going to give me 16 minus 16, which is 0. So this is actually a parabola. Okay. So you might be wondering, how in the world is that a parabola? You've got an x squared and a y squared. Okay. I'm going to go ahead and show you that tomorrow. Okay, we're not going to have time to do it today, but tomorrow after the quiz, we'll go ahead and take care of that. Okay. Now you'll notice this one right here, 4x squared plus 3y squared minus 2x plus 5y minus 60. Okay. This one, you could probably go ahead and look at and be reasonably certain about what it is, because there is no xy term. Okay. Well, you'll notice there is an x squared and a y squared. They're both positive, so that would lead me to believe it's either a circle or an ellipse. Which one does it actually turn out to be? What do you think? Okay. Are you guessing there was a little bit of inclination at the end of that? Okay. What's that? Oh, hello. Hello, sir. How are you?
Can I borrow Aiden for just a moment?
Yes, Aiden. Is this a crossover? It's actually pretty cool because we also have Ms. Castle and Mr. Reynolds out there. That's cool. We can have them all in here in math. Oh, he shut the door. Okay. Yeah. Anyways, let's go ahead and see what b squared minus 4ac is going to give me. So I mentioned this a minute ago. There is no xy term, so b is 0. So that's 0 squared minus 4 times a, that's the x squared coefficient, times c, that's the y squared coefficient. Okay. Well, you'll notice we don't even really have to finish. You know your answer is going to be what type of number. It's going to be negative. In fact, it's a negative 48. Okay, 4 times 4 times 3. Now, here's the thing. If you end up with a negative value, well, then it's either a circle or an ellipse. Now, to figure out which one, then you want to look at those conditions. Okay, if it's a circle, both b has to be 0 and a has to equal c. Okay, both of those statements would have to be true. Now, if it's an ellipse, only one of those two statements has to be true. Either b won't be 0 or a will not equal c. In fact, do you remember those words and or? Do they kind of sound familiar, maybe from the beginning of the school year? What words am I thinking of when I say and or? It starts with an I and a U. Intersection and union. Do you guys remember those? Remember us doing sets and complements at the beginning of the school year? Kind of. It's been a while. A little while. Okay. All right. But, well, let's see. Is B equal to 0? That is true. Okay. Does A equal C? No. Both of those would have to be true if it's a circle, so it has to be an ellipse. Okay. So either B is not equal to 0. Okay. Well, that's not the case. Or A does not equal C. And here A does not equal C. This is an ellipse. Okay. All right. And let's try this last one right here. Okay. How about Jacob? What is my value of B from this equation? Okay, that is 4. It's the xy coefficient. So I'm going to say 4 squared minus 4 times A. Jack, can you help me out? 10. Okay. Times C. Alyssa? Oh, not 24. Okay, it's the y squared coefficient. Negative 12. There we go. And you can probably already tell just by looking at this, what are the two negatives going to do? They're going to cancel, give you a positive, so I know I've got to be coming up with a positive number. In fact, this is going to be 16 plus 480, which is 496, but because it's a positive number, this would be a hyperbola. There we go. All right, easy? Anybody have any problems? All right, well, don't forget, remember what's happening tomorrow. Okay, ellipse quiz. All right, so I am here in the morning if you have any last questions or concerns, and that bell should be ringing very quickly. Okay, thank you very much, guys. Let me go ahead and erase all this.